Alright, in this one, we are looking at the mean weight of 20-year-old women, and it says the mean weight is 128 pounds. And here we are looking at a random sample of 40 vegetarian women, and it shows that the mean weight of the 40 women that we selected has a mean of 122 and standard deviation of 15 pounds. So here our n is equal to 40. The sample of our the mean of our sample is 122 pounds, and the standard deviation is 15. And we want to know, is this evidence that the vegetarian women, because this is a sample of vegetarian women, if that is evidence that the mean for the vegetarian women is different from the mean of all women. So we write a null hypothesis and an alternative hypothesis. In this case, the null is that the mean is the same as for all women, and the alternative is in part A, it says determine if the mean weight is significantly less than 128 pounds. So we're going to write less than 128, okay? And here, mu represents the mean weight of all 20-year-old vegetarian women. Okay, so here we have to find our test statistic, which is what we observed minus what is stated by the null hypothesis divided by our standard error. What we observed was the average was 122. What the null hypothesis states is that the mean is 128, and here we got to figure out our standard error. Our standard error is the standard deviation s divided by the square root of n. In this case, 15 divided by the square root of 40. So I'm going to punch that into the calculator. 15 divided by the square root of 40. That gives me 2.37. 2.37, here I'll go out a couple more decimals. 2.3717. That's my standard error. And so my test statistic is 122 minus 128 divided by that answer, 2.530, if I round up. And so, oh, I'm sorry, this is negative 2.530. So the picture shows us out at negative 2.53, and we want to know what is the area over here. And it's a one-sided test because it's a less than sign. It's only two-sided when it's a not equal to. So we're just looking for what is the area here. And so for that, we go to the T table, and we look up 39 degrees of freedom. Now when we go to the T table, we don't actually see 39 degrees of freedom exactly. Okay, so anytime you don't see the proper degrees of freedom, round down. So I'm going to go down to degrees of freedom 30. Okay, you always round down. So even though 40 is much closer, you always round down. And so when I look at 30 degrees of freedom, I'm looking for the number 2.53, and I see that 2.530 is between, so 2.53 is between, it's between two numbers, 2.457, which corresponds to a tail probability of 0.01, and it's also between 2.750, which corresponds to a tail probability of 0.005. Okay, so 2.53 fits in between there. So my tail probability is going to be in between 0.01 and 0.005. It's a one-sided test, so in this case I do not need to double my tail probability, so my p-value itself is going to be less than 0.01, but be bigger than 0.005. So we don't know exactly what it is, but we do know it's in between those two numbers. So because my p-value, if my alpha, it says uses significance level of 0.05, my p-value is less than alpha. And so here we reject the null hypothesis. And we have evidence that the mean weight of vegetarian women is significantly less than other women, than the rest of the women. Alright, and so here, so that's part A. Okay, so please make sure you can set up the null and alternative hypotheses, figure out your test statistic, and then find the corresponding p-value. Part B asks us to try it with a sample of 100 women instead of 40 women. Okay, and so I'm going to, the work is going to be very similar, but we're going to have a sample of 100 women. Okay, so in this case, my n is now 100 for part B. So my standard error is going to be s over the square root of n. 15 divided by the square root of 100 is going to give me 1.5. Alright, and so over here, my standard error, I'm going to plug in 1.5, and I do 122 minus 128 divided by 1.5, and I get a t-score of negative 4.0. So in my picture, it looks just the same, except now my tail probability, I'm looking for negative 4.0, and I still want to know what is the area in one of these tails. And now the degrees of freedom that I have is n minus 1, so I have 99 degrees of freedom. Again, when I go to the t-table, I don't see 99 degrees of freedom, so I have to pick out, I have to round down. So in the table that I'm using, this table I'm using the one in the book, and so the next thing that's closest is 80 degrees of freedom. Now, depending on the t-table that you're using, you might have a different number of degrees of freedom. But in this case, I look for 80 degrees of freedom, and the smallest number that I see is 2.639, which corresponds to a tail probability of 0.005, and this book actually goes out to 0.001, which gives me a value of 3.195. Okay, so the number 4 is beyond this number. Okay, if you're using a different t-table, maybe the number 4, all you see is that this 4 is very far away. We're 4 standard errors away from the mean, which just means we're very far away. So it's our p-value, whatever it is, our tail probability. In this case, because I'm using my table that goes out to 3.195, I just know that my tail probability is going to be less than 0.001. Okay, so my p-value is less than 0.001. And so again, here I'm going to reject the null hypothesis, and I come to the same conclusion that we have evidence that vegetarian women's mean weight is less than non-vegetarian women. Okay, and then the last part, explain what causes the difference. Again, for here, we have a larger n. So standard error decreases. And that makes any difference to be more pronounced. That's it.